All right, let's start with linear law. Inshallah, today's objective is that we are going to cover the explanation of linear law. So what is actually linear law? So let's recall and then we'll see what how to go about it, inshallah. The first thing that we have learned up till now is in coordinate geometry. We have studied coordinate geometry in O levels, in O-level mathematics, in IGCSE mathematics, as well as even we have studied coordinate geometry in AS level, pure maths 1, right? So coordinate geometry has taught us that whenever you have to find the equation of a linear line, whenever you have to find the equation of a straight line, then the linear, for the linear equation, for a straight line is basically called a linear equation. If the power of x is 1, we call the equation a linear equation. So if we plot the graph of a linear equation, then it is a straight line. And to find the equation of a straight line, we always use the formula y equals to mx plus c. So this formula we have already studied before, and we also studied that there was another formula y minus y1 is equals to m x minus x1. And we used to apply this formula, and we used to give the equation of the straight line using this formula as well. However, as of now, we are focusing on y equals to mx plus c. So whenever we have to find the equation of a linear line, at times the equation of a line is given and we need to find the gradient. So it is being told that whenever the equation is given and you have to find the gradient and or y-intercept, then you have to transform a equation in the you have to transform the given equation to the form y equals to mx plus c, and from that converted form you can extract the gradient and the y-intercept. You can extract the values of m and c, right? So y equals to mx plus c, just recall that x and y were the variables and m and c were the constants. What was m? M was the gradient of that straight line. What was c? C was the y-intercept. Just to recall, what is the y-intercept? What is y-intercept? Y-intercept किसे कहा जाता है? So the line intersects the y-axis. The point where the line intersects the y-axis is known as the y-intercept. So if it is a graph of y against x and the equation is of the form y equals to mx plus c, then this point is known as c. The y-intercept is the point where the line crosses the y-axis. All right. So now what is linear law? Let's read this once. For two variables x and y related by y equals to mx plus c, the graph of y against x is a straight line and m and c are constants. So always remember, y and x are variables, m and c are constants. So m is the gradient, c is the y-intercept, both of which are constants. Variable is something that varies, that changes constantly, but constants are something that stays same throughout, right? So m and c are constants, y and x are variables. Now what do we actually have to study in the topic linear law? The linear law says and tells us that if we have been given a non-linear equation, a non-linear equation is an equation which is not actually linear, because so, and if even if we are going to plot it, we will be seeing a curve and not a line. If we are plotting a linear equation, a straight line is made. But if we are plotting a non-linear equation, then a curve is made. But the linear law tells us that even if an equation is non-linear, but if we transform that in the form y equals mx plus c, and we change the axis, instead of x, if we take some another variable, and if instead of y we take something else, then if we change the axis, the curve gets converted to a straight line. Just to give that idea, एक समझाने के लिए, एक नॉन लीनियर इक्वेशन लीनियर में कन्वर्ट हो जाएगा तो कर्व लाइन में कन्वर्ट हो जाएगी. A curve gets converted to a straight line. Now how to do that? So let's start with a very basic example just to give you that concept. So this is a line which has the equation y equals to mx plus c, and the gradient is m, right? The gradient, the slope of this line is m. Okay, linear law says transform a given relationship. A given relationship is definitely a non-linear equation, and we need to convert that non-linear equation to linear form. This is the concept of linear law. Convert and transform a non-linear equation to linear form. Now let's start off with a very simple example. Y equals to 2x square plus 3. What kind of an equation is this? So everyone knows that as there is a power of 2 on x, this is therefore a quadratic equation. This is a quadratic equation. Now, if we normally plot a quadratic equation, what do we get? We get a curve. So let's try it out. Let's try it out. Also, we need to see that whenever we are plotting on vertical axis, we are plotting y. On horizontal axis, we are plotting x. We say the graph of y against x. If on the vertical axis, let me change it, because over here the variables y and x are capital, so I'm writing capital Y and x only. Y equals mx, y equals mx plus c, right? Just to align that, because of over here capital Y and capital X are written, so I've written capital Y, capital X over here as well, right? Now, if we talk about this equation, then if we are plotting y on the vertical axis as per the routine, normally we do this, right? We take y on the vertical axis and x on the horizontal axis. So if we take y on the vertical axis and x on the horizontal axis, and if we plot the graph and if we draw a curve, we will call it the graph of y against x. Whichever variables we plot on the vertical and horizontal axis, accordingly we say that we are drawing the graph of this against this. So if you are taking y on the vertical axis and x on the vertical axis, we'll call it y against x, the graph of y against x. वर्टिकल एक्सिस पर और हॉरिजॉन्टल एक्सिस पर हम जो भी वेरिएबल्स लेते हैं उसी हिसाब से उसका नाम हो जाता है. तो वर्टिकल पे अगर हम y ले रहे हैं, हॉरिजॉन्टल पे x ले रहे हैं, तो हम कहेंगे द ग्राफ ऑफ y अगेंस्ट x. तो now when we are plotting a non-linear equation and we are drawing the graph of y against x, then we will see that a curve will be made. As per the normal routine work, if we are doing, if we are taking on the horizontal axis x and on the vertical axis y, and if we are going to draw a graph of y against x, then we will see that a curve will be made. Sir, why is it a curve? Because the given equation is non-linear equation. And it is non-linear. What kind of a non-linear equation it is? It is a quadratic equation. This means a quadratic curve will be made. Now you must have heard how to sketch. For sketching, you have to take a few values of x and substitute in the equation, and then you get the values of y, and then you plot. So just check it out. If we take few values of x and we also take few values of y, then the coordinates will be -2, 11, -1, 5, 0, 3, 1, 5, 2, 11. Just try it out. If we substitute -2 over here, then 2 times 2 times -2 whole square. -2 whole square is 4. 4 times 2 is 8. 8 plus 3 is 11. So if we are going to substitute -2, the value of y will be 11. If we substitute x -1 inside the given equation, the value of y will be 5. If we are going to substitute 0, the value of y will be 3. Substituting 1 will give us 5. Substituting 2 will give us 11. So if we see the coordinates are -2, 11, then -1, 5, then 0, 3, then 1, 5, then 2, 11. Now we have how many coordinates? 1, 2, 3, 4, 5. Altogether, we have 5 coordinates in front of us. if we are going to plot these 5 coordinates, a curve will be made, right? A curve will be made. Let me change this. I have to draw it like this. Okay, now it's fine. Now let me draw and plot it. This is why this is the origin. So this is -1, this is -2, -2, -1, 0, 1 and 2. -2, 11. A shape like this will be made. A quadratic curve like this will be made. Now just check it out. -2. Let's suppose this is 11. -2, 11. And also 2, 11. And 0, 3. Let's suppose this is 3. So we see a -1, 5. Let's suppose this over here, here it is 5. Just don't check out the scale because it's just to clear the concept as of now. We are not focusing on the scale right now. So -2, -2, 11, -1, 5, 0, 3, 1, 5, 1, 5, and then 2, 11. So if we are going to plot the graph of y against x, we'll see that a curve will be made. And that curve will be a quadratic curve. Up till now, I have not applied linear law. Up till now, I have not applied linear law. I'm just telling you the normal routine practice that we were following. The normal routine practice in which we used to plot x comma y. X comma y. X on the horizontal axis and y on the vertical axis. Now what linear law tells us? Linear law tells us that convert the given equation in the form y equals to mx plus c and accordingly change the axis. How to do that? Now this is something that we need to learn. So if the equation, always write the equation first. The equation is y equals to 2x square plus 3. The equation is y equals to 2x square plus 3. Then if we write y equals to mx plus c, then we can see that in place of y, there is a y. In place of x, there is x square. And if we are going to take, now these capital Y and capital X are dummy variables. Actual variables are small y and small x. So as this particular equation is an explicit equation, this is already converted in the form y equals to mx plus c. There are going to be cases where we are going to convert into that form as well. But over here, this is an explicit equation which is already in the form y equals to mx plus c. We just need to see that what are we going to take in place of y on the vertical axis and what are we going to take on the horizontal axis in place of x. So if we write the given equation y equals to 2x square plus 3 and then we write linear equation to apply the linear law, then in place of y we see small y, in place of x we see small x square. So this means that if we are going to plot and if we are going to take small y on the vertical axis and if we are going to take small x square on the horizontal axis, then a straight line will be formed, which will be having the gradient 2 and and the intercept will be 3. So this means now we are not going to take y on the vertical axis and x on the horizontal axis. Rather, we are going to change the axis of the curve. So what are we going to do now? Just check it out. Now I'm going to take x square on the horizontal axis and y on the vertical axis. Because if this equation is in the form y equals to mx plus c, then in place of y, we have small y. In place of x, we have x square. In place of m, we have 2. And in place of c, we have 3. So if we are going to take on the x-axis, on the horizontal axis, we take x square, and on the vertical axis, we take y, then a straight line will be formed. So let's try it out. The values of x that we took to plot this first graph, which was a quadratic curve, the values of x that we took were negative 2, 11, negative 1, 5, 0, 3, 1, 5, and 2, 11, right? Now, instead of taking x, y, let's take x square, y. Why? Because linear law is telling us that in place of x, there is x square. So on the horizontal axis, don't take x, rather take x square. In place of y, there is y only. So in place of y, take y on the vertical axis. If there would have been y cube, let's suppose, then in place of y, if we would be taking y cube, if in place of x, we would be taking x square, even then a linear equation, even then we will get a straight line. So whatever is written in place of y, that is to be taken on the vertical axis. जो भी y की जगह पर है उसे वर्टिकल एक्सिस पर लेना होगा. जो भी x की जगह पर है उसे हॉरिजॉन्टल एक्सिस पर लेना होगा. Whatever is in place of x, we need to take it on the horizontal axis. Now, in place of x, I'm taking x square. In place of y, I'm taking y. So I've actually changed the axis. The concept of linear law tells us that do not keep the axis fixed. Do not take x and y only on the axis. Rather, change the axis. Change the variables. Change the variable that you're taking on the axis. So we are taking x square and y. So we'll say the graph of y against x square will be a linear line. Because we have changed the axis, that is why now we'll not be seeing a curve. Rather, we'll be seeing a straight line. Because we have used linear law and then we have transformed it into linear form. So now, if instead of x, y, we are going to take x square, y. So x square, y mein, if we are going to take x square, y, then the coordinates will be 4, 11. Now let me write the coordinates over here. X square, y. The coordinates will be 4, 11. Then 1, 5. Then 0, 3. Now if we check out, squaring negative 2 will give us 4. Squaring negative 1 will give us 1. Squaring 0 will give us 0. Squaring 1 will give us 1. Squaring 2 will give us 4. So 4, 11, 1, 5, 0, 3. And then repeat. This 1, 5 is same as this 1, 5. This 4, 11 is same as this 4, 11. So they are same. So 4, 11, 1, 5, and 0, 3 are the three coordinates that we need to plot. So now let's plot 0, 3, then 1, 5, and then 4, 11. So now if we are going to plot 1, 0, 3, 1, 5, and a straight line will be formed. So we can say 4, 11. Somewhere over here will be 4, and somewhere over here will be 11. This coordinates 4, 11. This will be 1, 5. And this first one will be 0, 3. So if we are going to plot the three coordinates, now we can see that a straight line is formed. Previously, we were taking y on the vertical axis and x on the horizontal axis. So we were seeing a quadratic curve. But now, because this non-linear equation has been converted in the form y equals to mx plus c, although we have not converted it, this was already in that form. If it was not already in that form, we would have converted into that form. Over here, it was already a converted equation. That is why we call it an explicit equation. I'll also be covering implicit equation, and we have to convert, in which we have to convert to y equals to mx plus c by ourselves. But over here, no need to convert, just need to compare. In place of y, we take y. In place of x, we take x square. So if we are going to plot y against x, then it will be a curve. But if you are going to plot y against x square, then this will be a straight line. So this is what is written over here. The graph of y against x is a curve, and the graph of y against x square is a straight line. It is always, it is not like this graph of x square against y. No, not x square against y. First we read the variable on the vertical axis and then the variable on the horizontal axis is read. सबसे पहले vertical axis पे जो variable होगा उसको पढ़ेंगे, फिर horizontal वाले को पढ़ेंगे. So we'll not say x square against y, we'll say y against x square. Over here we say y against x. So by changing the axis, by changing the variables that we by changing the variables that we take, by changing the variables that we take on the axis, we have transformed a non-linear equation to linear form. I think I've tried my best to communicate the concept. Just acknowledge if you have been able to understand or not. Please. If there's anything that you need to ask, you can ask, or else you can tell me that it is clear. All right, great. Hopefully you people have written it as well. If not, then take a screenshot. All right, written. Perfect. Okay, then moving on towards example number 2. Now, if you are going to plot the graph of y against x, then it will be, definitely it will not be a straight line, right? But if we compare this equation and if we write y equals mx plus c, y equals mx plus c, this is the linear law. Okay, and another thing that I wanted to tell you was that even if you were to take the gradient using these points, 11 minus 5 upon 4 minus 1, 11 minus 5 upon 4 minus 1. So 11 minus 5 is 6 and 6 upon 3. So the gradient is 2. Just check out. If we have plotted x square comma y, then if we are going to use any 2 points to find the gradient will definitely be 2. And as we are already seeing, even the y-intercept is 3. The y-intercept is 3. Because there is a y on the vertical axis, we call it y-intercept. If there is something other than y on the vertical axis, then we'll say that intercept only. Like we'll give the name of the intercept according to what the variable on the vertical axis is. We will give the name to the intercept according to what the variable on the vertical axis is, right? So if we are writing y equals to mx plus c, let me rewrite once again. Y equals to mx plus c. Then now we just need to compare. In place of y, what we need to take? 1 upon y. In place of x, what we need to take? We need to take root x. And if we are going to take 1 upon y on the vertical axis, and if we are going to take root x on the horizontal axis, then the gradient that we are going to get will be a, and the intercept that we are going to get will be b. And this intercept is going to be called 1 upon y intercept. Rather than calling it y intercept, we will call it 1 upon y intercept. So over here, the y intercept is 1 over, sorry, the y intercept is, the 1 upon y intercept is b. So usually the c is called y intercept. But now over here, because we are plotting the graph of 1 upon y against root x, so the intercept that we are going to call will not be y-intercept, rather it will be 1 upon y-intercept. So the name of the intercept depends upon what we take on the vertical axis. So now a straight line will be formed. I've not given this equation. The above equation was given, the numbers were given, but over here there are no numbers given. So we don't need to find out anything. If the values of a and b were given, we would have been able to see and plot and see that a curve will not be made, rather a line will be made. So just, we have already covered that particular thing by substituting values. By substituting the values, we have already seen in the first example. So let's not repeat that again and again. Just to decide that which variables which variable are we going to take on the vertical axis? So over here we will take 1 upon y, and on the horizontal axis I'm going to take root x. And I will say, and the intercept will not be y-intercept, it will be 1 upon y-intercept. And this intercept will be b. The intercept will be b. And the gradient of this line will be equal to a. And which kind of graph have we plotted? So I'm writing, this is a graph of 1 upon y against root x. Graph of y against root x. The graph of 1 upon y against root x. The intercept will be 1 upon y-intercept. And because on vertical we have 1 upon y, on horizontal we have root x, we'll call it the graph of 1 upon y against root x. I think I've made myself clear. Okay, another thing. What will be the coordinates? If there is x on the horizontal axis and y on the vertical axis, the coordinates are x comma y. But if whenever someone is asking what are the coordinates, right? Are the coordinates x comma y or x square comma y or something else? Then we need to see the axis. On the horizontal axis, there is root x. On the vertical axis, there is 1 over y. So the coordinates will not be x comma y. Rather, the coordinates will be root x comma 1 upon y. Because this is the biggest confusion that students face. If the coordinates are given, let's suppose 2 comma 11 are the coordinates given by the examiner. The students usually are mistaken and they think that x comma y is given. They think that the value of x is 2 and the value of y is 11. No, it's not like that. Before we decide, we need to check out the axis of the curve. So if the coordinates are 2 comma 11 given, and if there is root x on the horizontal axis and 1 upon y on the vertical axis, then we need to know that root x equals 2 and 1 upon y equals to 11. 2 comma 11 is not x comma y. The coordinates that are given will not always be x comma y. Rather, it will depend upon what the axes are, what the horizontal and vertical axes are. ऐसा नहीं है अंधाधुन आपने कोऑर्डिनेट देखे और आपने कह दिया कि x कॉमा y है. नहीं, कोऑर्डिनेट्स x कॉमा y नहीं होंगे हमेशा. हमें देखना पड़ेगा एक्सिस क्या है, हॉरिजॉन्टल एक्सिस पर क्या है, वर्टिकल एक्सिस पर क्या है. उस हिसाब से डिसाइड होगा कि यहाँ कोऑर्डिनेट्स को x कॉमा y बुलाना है या रूट x कॉमा 1 अपॉन y बुलाना है. I think I have been able to communicate myself. So this is another example of explicit equation which we didn't have to convert ourselves by ourselves. It was already converted. We just need to compare the given equation and see. We need to compare with the linear form, and we need to see what variable we need to take on the vertical axis and what on the horizontal axis, right? So just share your feedback and acknowledge if you have been able to understand it. Is it clear to everyone? Please acknowledge. All right, moving forward. Now moving towards more examples. And now these are the kinds of examples that usually come in P3 exam. You know why? Because the P3 syllabus restricts the P3 syllabus tells us that the domain of linear law is limited in P3. इसका एक restricted domain है. मतलब not everything is under the linear law in P3. in additional mathematics of O levels and IGCSE, most of very few students opt for AdMaths. So in additional mathematics, if all the above kind of equations that I was explaining till now are do come in the exam. But as far as P3 exam syllabus is concerned, we have to deal with implicit equations which are not already in the form y equals to mx plus c. Rather, we need to convert them into y equals to mx plus c. As of now, I covered those examples just to clarify the concept that if there is a non-linear equation, then we need to convert it into linear form and we need to change the axis. Now, when the concept is cleared, now I can tell you that as per our P3 syllabus, the examples 3 and 4 are the third and fourth examples are more valid as compared to first and second. But first and second told us the concept. Now, to polish that, let's check out third and fourth example. Third and fourth exam type questions है क्योंकि exam में लिखा हुआ है use of logarithms to convert a non-linear equation to linear form. So whichever example we are going to check out, we'll be seeing वो third and fourth example की तरह के नजर आएंगे. Now what to do? Now y equals to ka power x. Y equals to ka power x. This is a non-linear equation, but this is not in the form y equals to mx plus c. So what we need to do? So always remember, whenever the given equation is not in linear form, we need to take LG or LN on both the sides. So which of LN or LG will we take? Will we be guided by the examiner? As at times the examiner guides something or gives some information which tells us whether we have to take LG or LN. But if the examiner is silent and we are not being guided by the examiner, then we can take LG or LN both. We know that LG is known as common logarithm, log with the base of 10, and ln is known as the natural logarithm, log with the base of e. So we can take LG as well and we can take ln as well if nothing is specified. If there's something specified or if certain information is given by the examiner, that we need to follow that. But if nothing is written, if nothing is given, then we need to we can take any of LG or ln. So over here, I'm taking LG on both sides. Take LG on both sides. Taking LG on both sides. Okay, so let's take the LGY equals LG KAX. Now we see that within the brackets there's a product of K and A power X. K is a separate term, A power X is a separate term. So A with the power, A is the base and the power is X. K is the base and the power is 1. So there are two terms, K and A power X. So this means there's a product. So we'll use product law. So LGY equals to LGK plus LG A power X. LGY is equals to LGK plus LGA power X. Now, this X as per the power law will come at the back. So we'll write X LGA plus LGK and this is LGY. You know why have I brought this LGAX and changed its place and swapped it with LGK? Because in y equals to mx plus c, the constant comes at the end and the variable comes in the middle. And the variable, then variable along with a constant and then a constant. Right? So that is why I've changed the sequence. Now, let me tell you one thing. We know that y and x are variables. So it is very, very essential for us to be able to identify which are variables and which are constants. So we need to know that k and a are constants. Because we know that the gradient and intercepts are constants, right? K and a are constants. Y and x are variables. Now LGK plus, because product gets converted into addition. So LGK as per the product law of logarithm that we have studied. So LGK plus LGA power x. Then as per the power law, x comes at the back. As per the power law, x comes at the back. So this is x LGA plus LGK. LGY is equals to x LGA plus LGK. Now we need to see that this equation is in the form, this was not originally in the form y equals to mx plus c. We had to take logarithms to convert it into linear form. So now if we write the linear law, y equals to mx plus c, then we can see that in place of y, we need to take LGY. In place of x, we need to take x. Now, some students can make mistakes. They say that in place of m, we are going to take x because m is first and x is first. So in place of m, we are going to take x. And in place of x, we are going to take LGA. Now, this is a conceptual blunder. You need to identify where the variable is. So this capital X is a dummy variable. This is a variable. And this small x is the variable. LGA will not be a variable because a is a constant. So LGA will also be a constant. So this means that x will be x and the gradient will be LGA. The gradient will be LGA and the intercept will be LGK. And the intercept will be called LGY intercept. Why? Because in place of on the y-axis, we are not taking y, we are taking LGY. On x-axis, we are taking x. And the gradient will then be LGA. So I'm writing it as well. Y equals LGY. X equals x. The gradient equals LGA. And the intercept equals LGK. And the graph will be made, and the graph will be graph of LGY against x. And the coordinates will be x comma LGY. The coordinates will not be x comma y. The coordinates will be x comma LGY. So we need to be very clear. We need to be very clear with the terminologies that we are going to say. We are not going to say y against x. We are going to say the graph of LGY against x will be a straight line. Then we'll not say the coordinates are x comma y. We'll say the coordinates are x comma LGY. So even if the coordinates are given by the examiner, the first coordinate will be the value of x. The second coordinate will not be y. It will be LGY. So if let's suppose 2 comma 5 is written, then the value of x is 2 and this 5 is not the value of y. This is the value of LGY. So LGY is equals to 5. X equals 2 and LGY equals 5. So now if we are going to draw the axis, then on the horizontal axis, we are going to take x. On the vertical axis, we are going to take LGY. And then definitely if you are going to draw and plot the points, as of now, points cannot be taken as there are no values given because even the constants are unknown. So just to give you an idea, if you're going to plot the graph of LGY against x, then the graph of LGY against x will be a straight line with coordinates x comma LGY. And the LGY intercept would be LGK. And the gradient would be LGA. Gradient would be LGA and the intercept, the LGY intercept would be LGK. So this was an implicit equation, which was not already, the above two examples were explicit equations, which were explicitly in that form. So we just had to compare and write. But over here, the equation was implicit. It was implicitly shown. It was not explicitly in the form y equals to mx plus c. Rather, we had to take logarithms, LG or ln on both sides to transform it into linear form. And then we were able to identify that which variables are we going to take on the vertical and horizontal axis. I think I have been able to communicate the concepts very clearly. Even then, if there are any doubts, please let me know. कोई भी मसला है, कोई भी confusion है, बता दें. नहीं है कोई confusion, just write clear that yes, you are clear, so that I can move forward. Okay, then moving on towards y equals to kx power n. This is very similar to what we have already covered, with just one difference that we are going to identify only once we have applied LG or LN on both the sides. Again, we can take either LG or LN on both the sides. In the third example, we took LG. So now, just to change that, let's take LN on both sides. So LN on both the sides. Take LN on both sides. So this is ln y equals to ln k plus ln x power n. Now, as per the power law, this n will come at the back. And I will take it over here. N ln x plus ln k, because the pure constant comes at the end, and this is ln y. So ln y is equals to n ln x plus ln k. What is the difference in the third and fourth example? In the third example, the x was in the variable x was the power of a. The variable x was in the power. But over here, the variable x is in the base. The power is a constant. Over here, the base was a constant, the power was a variable. Over here, the base is the variable and the power is the constant. So this is the difference. So now when we have taken ln on both the sides, then we know that again, this will be a product. So product law will be applied. So ln k plus ln x to the power of n. And as per power law, n will come at the back. N ln x plus ln k. Now, if we are going to compare y equals mx plus c, in place of y, we are going to take ln y. In place of x, we are going to take ln x. The gradient will be n, and the intercept will be ln k. So now I'm writing it over here. If I take ln y on the vertical axis, if I take ln x on the horizontal axis, the gradient would be the gradient would be n, and the intercept this time would not be called y-intercept. Rather, it will be called ln y-intercept, because we'll be taking ln y on the vertical axis. So the intercept is not y-intercept, it is ln y-intercept. So what is ln y-intercept? Ln y-intercept is ln k. So now if you are going to draw a line, if you're going to draw a graph, then on the vertical axis we will take on the vertical axis we will take ln y. On the horizontal axis we are going to take ln x, and we'll call it graph of ln y against ln x. The coordinates will not be x comma y. The coordinates will be ln x comma ln y. And if you are going to draw a straight line, then the ln y intercept would be ln k, and the gradient would be, the gradient of this line will be equals to n, right? So this is the fourth example, which tells us how to convert a non-linear equation, how to convert an implicit non-linear equation to linear form by applying linear law. So by taking logarithms on both the sides, and this is the area that is a part of our syllabus. Use of logarithms to transform a non-linear equation to linear form. So in the third and the fourth example, we have applied the requirement of the syllabus. Whatever was demanded by the syllabus, we have done that in example 3 and example number 4. So this is the fourth example that I have covered. Copy this down and let me know if are you clear till here? Is everything clear? The linear law explanation is this much only. The explanation is very short, and even the occurrence of linear law in past papers is very less. Like altogether, if in from 2009 to 2022, I guess altogether there are at max 10 questions. So if in altogether, let's suppose around 65, 70 past papers, in 65 or 70 papers, it came just 10 times. So just very low occurrence, but we never know what comes in our exam. So we have to be clear conceptually with everything, and we need to be well prepared for each and every topic, right? And we are not going to base ourselves on assumptions or on like guess that, do you think, sir, linear law is going to come this time? It came last time, so I think it will not come this time. So let's not study that. We are not going to do any such thing. ऐसा कुछ नहीं करने वाले. सर ये नहीं आया पिछले साल या इस साल आ जाएगा, पिछले साल आ गया था इस साल नहीं आएगा, ऐसी कोई ड्रामेबाजी नहीं चलेगी. आपने देना है, आपको सब कुछ पढ़ना है, and you have to be very well prepared with everything. I think I have made myself clear. Need an acknowledgement. Are you clear with this fourth example? Yes. Yes or no? Okay, great. So we are clear. Alhamdulillah. Now we are in a position to move on towards the past paper questions to check out how do we apply linear law, right? So let's start. All right. So the very first question is a 6-mark question that came in June 2010. Paper 3-1, question number 3. Question number 1, let's read it out and then I'll apply it. The variables x and y satisfy the equation x power n times y equals c, where n and c are constants. So examiner has already identified and told us that n and c are the constants. X and y are the variables. So x and y are the variables, n and c are the constants. So on the vertical and on the horizontal axis, we are going to take whatever will come on the vertical axis will be a variable. Whatever will come on the horizontal axis will be a variable. So something which involves x and y will be coming on the horizontal and vertical axis, where n and c are constants. Now, when x is 1.10, y is 5.20. When x is 3.20, y is 1.05. So if we check out part number 1, we are hardly able to identify that whether linear law will be applied it over here or not. Why? Because we have been given a simple equation and we have been given the simple pairs, x 1.1, y 5.2, x 3.2, y 1.05. So there is no need of linear law in part number 1. At times, students think that this is an implicit equation. Let's apply LG or ln on both the sides. And then we apply linear, then we convert it into linear form. And then we substitute x and y. Yes, that can be done as well. But that can increase the burden on you, and that can increase the work. That can be a source of additional burden on you, because this can be dealt with this can be dealt with easily, but you are just increasing your task by taking LG or LN on both the sides. ऐसा लगता है बाज़ औक़ात ना कि LG LN लेंगे, क्योंकि इस तरह की इक्वेशन एक्सप्लेनेशन में मैंने बताया कि LG LN लेंगे, but over here we don't have to do like that. What will we do? because we have been given an equation which involves x and y, and we have been given two pairs which involves x and y. So we just need to substitute. So let's substitute the first pair. X is 1.1. So 1.1 power n multiplied by y, which is 5.2 equals to c. So this is the first equation. After substituting the first pair, then substituting the second pair. When x is 3.2, when x is 3.2, y is 1.05. So when x is 3.2, y is 1.05, 3.2 to the power of n times 1.05 equals c. So in place of x, we have substituted 3.2. In place of y, we have substituted 1.05, and the power n remains n and equals to c. So now we can see that there are two equations that have been formed, and we will solve the two equations simultaneously to find the values of c and n. So ultimately, we need to find the values of c and n. Okay, now how to solve them simultaneously? Now we know that this is also c and this is also c. So equating them, c is the subject in both the equations. So we'll simply be equating this with this. Let's equate both of these. So 1.1 to the power of n times 5.2 equals 3.2 to the power of n times 1.05. Sorry. Yes. So over here, I've draw our bracket. Okay. So 1.1 to the power of n times 5.2 equals 3.2 to the power of n times 1.05. Then what is going to be the next step? Then logarithms has told us, then when we are discussing the laws of indices, the bases are different, the powers are same. So we just need to divide them and take n as the common power. So let's cross multiply 5.2 divided by 1.05, 3.2 power n divided by 1.1 to the power of n, 3.2 power n divided by 1.2 power n, sorry, 3.2 power n divided by 1.1 power n. And then as per the law of same index, the power are the same. So 3.2 divided by 1.1 whole power n equals 5.2 divided by 1.05. Now we can convert this into decimal, and if you are going to convert, then we need to remember that the workings will be in 5 significant figures and the final answer will be in 3 significant figures. Always remember, as a general instruction given by the examiner on the first page of your question paper, non-exact numerical answers to be given correct to 3 significant figures unless otherwise stated. In case of angle in degrees, the accuracy will be 1 decimal place. So for angle in radians or for non-angles, the accuracy is the accuracy of final answer is 3SF, and for angle in degrees, the accuracy is 1 decimal place. So I always tell my students that always work at 2 accuracy higher than the accuracy required. So we need to give our answer as a general instruction given by the examiner. We need to give our final answer in 3SF. So we'll be working in 5 significant figures. And in case of angle in degrees, where the answer will be required in 1 decimal place, the working will be in 3 decimal places. Final answer 1 decimal place, working 3 decimal places. So we are going to, our next topic will be trigonometry, inshallah. So there we are going to cover this. And we'll be seeing how to apply that, right? So because in trigonometry topic, at times the questions involve radians, at times it involves degrees. So we need to be very well versed with trigonometry of AS as well, because AS trigonometry is will directly be involved in A2 trigonometry. A2 trigonometry has certain new concepts, but the concepts of AS needs to be polished. So I'll say that it is the right time to review the trigonometry of AS, so that when I'm covering the trigonometry of A2, you at least know that what are the basic concepts of trigonometry, because AS trigonometry will be assumed for studying A2 trigonometry. So 3.2 upon 1.1 whole power n is equals to 5.2 divided by 1.05. Then we know that there is a variable in the power No, n is a constant. Sorry. N is a constant, but if we need to bring n down, we need to take LG or ln on both the sides. We can take LG as well. We can take ln as well. There is no problem. Then if we take ln on both the sides, then n will come at the back. I've just skipped one of the steps. I will take ln over here. I'll take ln over here. Then n, as per the power law, will come at the back. So it will become n ln 3.2 upon 1.1. And this will be equals to ln 5.2 upon 1.05. So n ln 3.2 upon 1.1 is equals to ln 5.2 upon 1.05. Then if you are going to calculate this, and we are going to calculate this, and if you are going to divide both, the value of n will be 1.4982. So the working is in 5 significant figures, and then we have rounded off in 3 significant figures. So 1.49 because of 9, because 9 will become 10 because of 8. So 9 will become 10, 49 will become 50. So 1.4982 will be converted to 1.50. The answer of n will be 1.50. Okay. So the answer of n will be 1.50. Okay. And then on the basis of n, we are going to find c. So we can substitute the value of n in equation number 1, or we can also substitute in equation number 2. But always remember that we are not going to substitute the 3 significant figure version. Rather, we have found the 5SF version, and this 5SF version is going to be substituted. We are going to substitute this 5SF version, because if we are not going to do that, the accuracy of C will be disturbed, and then we'll not be able to get the right answer of C. So now I am going to substitute 1.4982 in any one of the equations. So I've substituted in this equation, 3.2 to the power of 1.4982 times 1.05. If I am going to find this, the answer will be 5.9979, and the answer will be 6.00 in 3SF. In 3SF, 1.50, and in 3SF, 6.00. However, for finding C, when we substituted n, we cannot substitute 1.50. Rather, we'll substitute 1.4982. That is why I always suggest working in 5SF and final answer in 3SF. These accuracy guidelines are for non-angles or angle in radians as well, but not for angle in degrees. Everything, these accuracy guidelines are valid for everything except angle in degrees. So I've been able to cover part number 1 using method number 1. This was the recommended method, and this made our task very simpler, and I've covered this in detail. So are you all clear with method number 1? Just give me an acknowledgement. क्या सबको method number 1 समझ आ गया है? Is everyone clear? Okay, take a screenshot. You can take the screenshot now. Okay, great. Okay, if method 2, I told you people that although it was not required to take LG or LN on both the sides, you could have directly substituted and solved. Taking LG, LN on both the sides was not required. In part 2, we will be taking LG, LN. I'll see that part later. As of now, if someone, let's suppose, if someone is not substituting directly, rather they are taking LG or LN on both the sides, then what will happen? Will they be able to solve or not? So let's check it out. So they will take ln on both the sides. So because x power n multiplied by y, ln x power n plus ln y. Multiplication gets converted to addition. Product law will be applied. So ln x power n plus ln y is equals to ln c. Ln x power n plus ln y equals ln c. Now, this n as per the power law will come at the back. So n ln x plus ln y is equals to ln c. Here we'll take equals to sign. So n ln x plus ln y equals to ln c. Then, okay, then, okay, right. Then we have different methods, but one of the methods is that now we can substitute x and y, but if we are going to substitute x and y, then we are going to get things in terms of, if you're going to substitute x and y now, then first pair, if we are going to substitute, then we'll get the first equation. Then if you're going to substitute second pair, then we'll get the second equation, and then we can solve them simultaneously. There's another way as well. One way was substitute at this stage. Substitute the coordinates at this stage in place of x and y, but not in place of ln x and ln y, okay? The coordinates that are given, the values, they are not coordinates. These are not coordinates. These are values of x and y. So x 1.1, y 5.2, x 3.2, y 1.05. So if you are going to substitute x and y over here, then we'll get two equations that we can solve simultaneously. Now there's another approach to that. If I can substitute at this stage or at the later stage as well. But this later stage is basically conversion into the form y equals to mx plus c. But that I have done in part number 2, not in part number 1. In part number 1, as a method 2, if we take ln on both the sides, then after this stage we'll substitute x and y, and then we'll form two equations and solve simultaneously. But that would be a bit tough for us. So the better method was method number 1, right? So no need to go for taking LG or ln on both the sides. It was just to complicate yourselves with more added burden. And the method number 1 that I've done is more simpler and easier. However, I could have used method 2 as well in part number 1, but it is not recommended. But this something is already required in part number 2. Let's read it out. What part number 2 tells us? Explain why the graph of ln y against ln x is a straight line. ये बताएं ln y against ln x का ग्राफ straight line क्यों है? So now it is time to convert the equation x power n times y equals c in the form y equals mx plus c. If we need to explain why the graph is a straight line, we need to convert this implicit equation in the form y equals mx plus c, and then we need to show that ln y will be taken on the vertical axis, ln x will be taken on the horizontal axis, and if we are going to plot, then we'll get a linear graph. So this is what I've done. Taking ln on both the sides, then as per the power law, n comes at the back. N ln x plus ln y equals ln c. Then ln y equals minus ln x plus ln c. Now I have converted this equation in the form y equals mx plus c. In place of y, we are seeing ln y. In place of x, we are seeing ln x. So the gradient will be negative n, and the intercept will be, the ln y intercept will be ln c. So this is what I've written over here as well. Let me rewrite it more clearly. Y equals to mx plus c. So y equals ln y. X equals ln x. The gradient would be negative n. And the intercept would be ln c. So y equals ln y, x equals ln x, m equals negative n, and c equals ln c. So the ln y intercept will be ln c, right? And the coordinates will be ln x comma ln y. If you are going to draw the graph of ln y against ln x, then we'll say the coordinates of that graph will be ln x comma ln y. Ln x comma ln y. So now it was just a one mark question. Explain why the graph of ln y against ln x is a straight line. So the first thing that we are going to do is we'll take ln, or because over here now I told you that if it is an implicit equation, we can take LG or ln both. But why have we take ln over here? And why not LG? Because the examiner is asking for the explanation of ln y and ln x, not lgy and lgx. That is why we are taking ln on both the sides. And then we need to explain why ln y against x is a straight line by converting it into the form y equals to mx plus c, and by writing that y is ln y, x is ln x, and the gradient is negative n, and the intercept is ln c. We have actually explained, but it is always recommended to write a line that after converting the equation to the form y equals to mx plus c, the y will be ln. After converting into the form y equals to mx plus c, we can see that the graph of ln y against ln x is a straight line with gradient negative n and the intercept ln c. The ln y intercept will be ln c, and the gradient would be negative 9. This is, I've made the graph as well. The intercept would be ln c. The gradient would be negative n. The coordinates will be ln x comma ln y. On vertical axis we'll take ln y. On horizontal axis we are going to take ln x. Now what is this? What kind of working this is? Let me tell you this as well. This working is for part number 1, right? As I've already told you that you could have done this in part number 1 as well. Although I think that you people can get confused as well, but I'm just telling you as a possibility. As a possibility, the recommended approach was method number 1. But if someone has done this particular thing in part number 1 only, then they can substitute at this stage the values of x and y. They can also do one thing. After converting into y equals to mx plus c, they know that the coordinates are ln x comma ln y. So now if we are going to substitute the values of x and y that are given by the examiner, 1.1, 5.2, and 3.2 and 1.05. So if we are going to substitute over here, so if we are going to substitute x and y, then first pair 1.1 and 5.2. So it will become ln 1.1 comma ln 5.2. And if you are going to substitute x 3.2 and y 1.05, the coordinates will become ln 3.2 comma ln 1.05. तो coordinates हमारे इस तरह से हो जाएंगे, ये these two will become the coordinates. And when we have coordinates with us, ln x comma ln y are the coordinates. When we have two coordinates, we can find the gradient. The change in the y upon the difference of y coordinates upon the difference of x coordinates. So ln not 1.05 minus 5.2. No, because the graph is not of y against x. The graph is of ln y against ln x. So the coordinates that we are going to use for finding the gradient will not be x comma y. The coordinates will be ln x comma ln y. The coordinates will be ln x comma ln y. So by substituting x and y twice, the two pairs, we have got the two coordinates in terms of ln x and ln y. Now we can subtract ln 1.05 minus ln 5.2 divided by ln 3.2 minus ln 1.1. So we'll find the gradient, and we know that if the graph of ln y against ln x is plotted, the gradient will be negative n. So now when we have found the gradient, now we'll equate it to negative n, and then we'll get the value of n. So dekhe, at the top, the value of n was found in a different way. However, this was another way of finding the value of n. And then when the value of n has been found, we can substitute the value of n over here, and one of the coordinates can be substituted, ln 1.1 in place of ln x and ln 5.2 in place of ln y. And then we'll make ln c the subject, and from that we'll be able to find the value of c. So I think there was a bit of confusion. There might have been a chance of confusion because I've told multiple approaches. I'm not sure whether you people have been able to understand or not. I'm just reading the answer over here. Explain why the graph of ln y against ln x is a straight line. State that the graph of ln y against ln x has equation n ln x plus ln y equals ln c, which is linear in ln y and ln x, or has equation of the form nx plus y equals ln c. So look, first they have taken ln on both the sides, then they have transformed into the linear form, and then they have written which is linear in ln y and ln x, or has equation of the form where x is ln x and y is ln y, and is thus a straight line. So basically, this working for part 2, and then at the end writing this serves as an explanation. Converting a non-linear equation to linear form and then identifying y, x, m and c will basically serve as an explanation. You can just support it using one line as well, because explanation means something theoretical involved. So you can just support your answer by writing a line that the non-linear equation has been transformed to linear form. And if you are going to plot ln y against ln x, then the gradient will be negative n. The intercept, the ln y intercept would be ln c, and therefore it would be a straight line. We can write a line like that. This statement is from marking scheme, so you can refer to this as well. I think I've tried to make myself clear. Take a screenshot of this entire question and acknowledge if you people have been able to understand or not. If anyone has faced any issues, किसी को कोई मसला है, कोई confusion है, तो वो पूछते हैं, मैं उसको समझा सकता हूँ. नहीं confusion, तो just let me know. चलें, great. Alhamdulillah. So you people are clear with whatever has been explained, right? Take a screenshot of this, and then inshallah I'll be uploading the past paper file as well. You can print that, you can solve the questions, and then whatever problems you have, you can bring to me in the next class. And if you are facing difficulties in solving the problems in the questions, I'll be solving more questions, inshallah. I think we should keep our class till here only for today. So see you all in the next class. Take good care of yourself. अपना बहुत सारा ख्याल रखिएगा. Assalamu alaikum wa rahmatullahi wa barakatuh.